Do you ever wonder why we need to change gears while we're driving? And what is the reason why we hear that horrible grinding noise while we're shifting gears? In this video, we will explain why cars need transmissions. And to do that, we will see the working principle of the clutch and manual transmission. In the first part of this video, we had the chance to understand the entire car ignition system. Now, we will see what we need to do in order to drive our vehicle. Suppose that the drive stick is put in neutral, which is the stage where no gear is engaged. Before we change the gear ratio, we have to press the clutch pedal on the left all the way down. The purpose of this pedal is to control the speed of our vehicle by partially engaging the clutch plate, which is a mechanical device made of one or more friction discs pressed tightly together. This plate allows the flywheel and the crankshaft to be gradually combined or disengaged with the gearbox. When the clutch pedal is pressed, in fact, the clutch diaphragm spring pulls the pressure plate away from the flywheel, thus disengaging the clutch from the engine. Now, with the clutch pedal pressed, we have to put the drive stick in this position. As we can see in this animation, the shift sleeve is sliding from the hub, which is fixed to the shaft, to the synchronizer cone of the first gear. Now that the first gear is selected, we have to release the clutch while slowly pressing down on the gas pedal in order to reconnect the engine to the gearbox and thus to move the vehicle forward. The clutch pedal plays a fundamental role in shifting gears. If we try to change gears without using it, the gear teeth can misalign with those of the shift sleeve, and the car will produce that grinding noise. But we will talk about this in a moment. Let's focus now on the manual transmission operation. In internal combustion engines, the RPM band within which the engine produces its peak torque is limited. For this reason, transmissions allow us to control the speed and torque available to the drive wheels by selecting different shift ratios for different driving conditions, whether the car speeds up or slows down. Lower gears have higher torque in order to achieve better acceleration, but at the same time, they have lower transmission speed, which is useful to start to drive from a standstill or climb a hill. On the other hand, higher gears will have higher transmission speeds and lower torque, which results in a decrease of acceleration, useful to travel along a straight section of the road at a constant speed. In order to change gears when the engine is running, the main shaft gears are equipped with a synchronizer cone teeth arrangement. A synchronizer ring helps to match the speed of the gears with that of the shaft. The synchronizer ring is capable of rotating along with the hub, but it is also free to slide axially. As we already said, if we try to change gears without using the clutch, the gear teeth can misalign with those of the shift sleeve, and suddenly we hear the grinding noise. Without the clutch, in fact, the flywheel is still connected to the transmission, and it supplies a strong external force to it. In this situation, the synchronizers don't have enough time to match speed of the gears with the one of the shaft. Furthermore, when we perform clutchless shifting, we are creating a large amount of unneeded wear on our synchronizers. With that in mind, we can now shift into second gear, third gear, fourth gear, and fifth gear. The reverse gear instead has a different configuration. More than 10 years in industrial supplies have led JIS to become a qualified partner for some of the most important automobile manufacturing companies, providing its technical support over a wide range of industrial components necessary during the production process of many types of vehicles. Here, we can notice that the reverse gear uses a 3-gear arrangement. Out of those, 1 is the idle gear. When the idle gear is pushed and connected to the other 2 gears, the output shaft will turn in the reverse direction. It is important to note that there's no synchronizer in the reverse gear, so we can only engage reverse from a standstill. The rotary motion of the output shaft is now transmitted via differential to the wheels. In the next video, we will explain how to drive on curves and how the steering system works. If you found this video useful, please let us know by leaving a like and a comment. You can also share it, and don't forget to subscribe to our YouTube channel. Find our next projects by visiting our website, JIScompany.com.